Hello, algebra kids. Today we're going to look at geometric sequences. Okay, geometric sequences are an exponential relationship, which means from one value to the next, they're going to either multiply or divide, as opposed to linear, where from one to the next you're going to add or subtract. So if you're looking at number 1, it goes from 5 to 10 to 20 to 40. Now, if it was linear, from 5 to 10, it goes up by 5. Then after 10, it would have been 15. So since it's not adding 5 each time, that should be a hint that it's going to be geometric, which is exponential. So hopefully you see that from 5 to 10, it's multiplying by 2. All right? And if you remember exponentials, right, remember it's y equals a times b to the x, where b is what you're multiplying by, and a is your y-intercept. Now here's the problem. Okay, when you're looking at when you're looking at sequences, remember this would be the y values. The x values would be starting with the first term, the second term, the third term, the fourth term. All right? And it's easier to work with the formula that I'm going to show you than to try to work backwards. So here's the bottom line. We're starting with 5. So y equals 5 times, our base is going to be our multiplier, times 2. But since we're starting with the first term, instead of starting at 0, we have to get backwards to 0, so we got to subtract 1. So instead of the exponent being x, it's going to be x minus 1. All right? Sometimes they're going to divide, all right? So you're going 270 to 90 to 30. So each time it's dividing by 3 or multiplying by a third. All right, so that's our multiplier. All right? All right, our next term would be 10 divided by 3, or 10 thirds, which we're going to just leave as a fraction. So now my equation, y equals, our first term is 270 times 1/3. But remember, we got to get from the first term, we have to get back to 0. So instead of just doing x, we got to do x minus 1. So this is our multiplier. This is where we're starting, but we're starting at 1. That's why we got to go x minus 1 instead of x. All right? All right, take a look here. Number 3. You're at -1. It goes to -6. It goes to -36. So the negative sign's not changing. So what you should notice is each time we're multiplying by 6. All right? So 6 is our base. So that goes inside. Again, we start at the first term. It starts at -1, and then your exponent's x minus 1. And this is the formula. A1 is the first term. R is what you're multiplying by. That's your factor. All right? So if I want the next term here, I would just multiply 216 times 6. 1,296. And if I went back to number 1, I forgot to find the next term. If I want the next term, it would be 40 times 2, which is 80. All right? Let me show you a couple more examples. All right? So look at number 4. It's going from 3 to 9 to 27. So you should notice it's multiplying by 3. All right? So if I want the next term, it would be 3 times 81, which would be 243. If you want to write the equation, all right, it starts at 3, so it's 3 times. Our base is going to be 3 because we're multiplying by 3. And remember, when you talk about a sequence, you always start with the first term. So you got to get from 1 back to 0. So to go backwards by 1, your exponent's got to be x minus 1. All right? If you want, you could use this formula, all right, which is given to you guys. So if you use it on a quiz or something, it's perfectly fine. Right, where A1 is the first term. So if I look at number 4, the first term is 3. R is what you're multiplying by. it's multiplying by 3. And you plug it in 3 for r, n minus 1 or x minus 1. The only difference is I like to put the r in parentheses, which is not shown on this formula. All right? All right, number 5. Write an explicit equation. All right, explicit is what we've been doing all along for the nth term of the following geometric sequence. All right, so if you look how fast these numbers are going up, right? It starts at 8, and then before you know it, you're over 500. That should be an indication that it's exponential because it's going up very rapidly. So already I'm thinking it's exponential. To get from 8 to 32, we're multiplying by 4. All right, now you might not be sure if times 4 would give you 128. So what you could do is 128 divided by 32, and that shows me I'm dividing by 4. So if you divide the number by the 1 before it, that should give you the factor, right? 512 divided by 128 is 4. So each time, it's multiplying by 4. So if I use my formula, an equals a1, which is the first term, times r to the n minus 1, I should be able to get my formula. My first term is 8. That's where I start. My ratio, or my factor, is 4 times n minus 1. Right? If you wrote y equals 8 times 4 to the x minus 1, that would be perfectly fine. All right? Let me do a couple more examples, but otherwise they're pretty much the same, and then you're going to practice. All right? Number 6. All right? Sometimes these numbers get really big. All right? But if you look, it starts out with a really, really big number, and then all of a sudden it's down to 6. When it decreases so fast like that, this should be an indication that it's exponential, which means it's a geometric type. All right? So I'm trying to see. To get from 4,000 to 800, I'm going to do 800 divided by the number before it, and that's 0.2. Right? I want to make sure it stays the same, so I'm going to check the next one. I'm going to do 160 divided by 800, which is 0.2. So every time we're multiplying by 0.2. All right? So that means our base is 0.2. It starts at 4,000, right? Think about an exponential function. This is where you start. This is what you multiply by. But again, we got to get from the first term back to 0, so we got to subtract 1. So this is our equation. an equals, I really should write n minus 1, or you could write y equals 4,000 times 0.2 to the x minus 1. Now, there's one other way you could write this, right? Remember, if you take 0.2 and you hit math, enter, enter, that'll change it to a fraction. So if you wrote y equals 4,000 times 1/5 to the x minus 1, that would be fine also. All right? All right, I'm going to have you try some of these. All right, I just want to point out that some of them are linear and some of them are exponential, so you have to check. So for example, let me do a couple more of these, and then you could try the rest. So if I look at number 9, it's going from 8 to 16 to 32 to 64. So we're trying to figure out how we're getting from one to the next. If I was adding 8 plus 8 would be 16. If I added 8 to 16, I would get 24, not 32. So this looks like we're not adding, we're multiplying. So this is geometric, right? 8 times 2 is 16. 16 times 2 is 32. So that's my multiplier. I'm starting at 8. We're multiplying by 2. And remember, you got to get backwards to get to 0. All right? Now, if you look at number 10, you may notice that from 2 to 6, you're adding 4. From 6 to 10, you're adding 4. So this one's arithmetic or linear. So remember, this is a different format. Remember, linear is mx plus b, where m is the amount that you're adding each time. So this one's going to be 4 times, but remember, you're starting with the first term. You always start at 1. I got to get back to 0, so instead of x, it's x minus 1 plus I started at 2. All right, or you could use this formula. Remember, AN equals A1 plus, okay, D times N minus 1. Where this is the difference, remember, from yesterday? And this is your first term. All right? Try these out, and I'm going to post the solutions. Keep in mind that sometimes it's going to be arithmetic, which is linear, you're adding, and sometimes it's going to be geometric, which is exponential, we're multiplying. All right? All right, have a good one. Talk to you soon.